Welcome in this third lecture of vector theorems. This lecture, as we have already discussed, this is especially for the students of Maharashtra State Board. So we are discussing vector theorems, right? In this class, I will be discussing two theorems which are till date, they have never asked these two theorems, but this is the part of your syllabus. Hence, I'm discussing this. Okay. So let me share the screen first. All right. So now, so we have done few things in the last class and last to last class. So the very important thing which I need today also is whenever the vectors are collinear, we say that one vector is a scalar multiplication of other two vectors. This part is very important for today's class also. And whenever the vectors are coplanar, that means one vector is a linear combination of remaining vectors. I'm saying remaining remaining two vectors, three vectors, whatever it can be. All right. So now let's begin with today's part. It is about the collinearity of 3 points. अगर आपने टेक्स्ट बुक देखा है तो टेक्स्ट बुक में आपके एक नोट में आपको या रिजल्ट्स में आपको दिया गया है about the statement which I have given on the board. Now what it says, three distinct points A, B, C. Now we are talking about collinearity of 3 points, not collinearity of three vectors. It is 3 points. Three distinct points A, B, and C with position vectors A bar, B bar, and C bar respectively. So position vectors are defined in the problem. Are collinear if and only if. Again here if and only if अपने को mention किया हुआ है. This is mentioned. Now there exist non-zero scalars. Non-zero scalars, very important. Non-zero scalars. Each and every word in the theorem is important. Non-zero scalars x, y, z such that xa bar plus yb bar plus zc bar is equal to 0 bar, and in that case x plus y plus z is equal to 0. now let us consider if wala part. Okay, now first of all you see that A, B, C are 3 points with position vectors A bar, B bar, C bar respectively. This is mentioned, this is given in the theorem itself or the question itself, we can say, right? Now they also say that A, B, C are collinear. Collinear points, see there is a difference between collinear points and collinear vectors. Collinear vectors can be either parallel or along same line, but collinear points are along the same line. Right now, what we have studied in the previous classes is if the three vectors are collinear, then if the two vectors are collinear, that means one vector is a scalar multiplication of another vector. Using this, if the two vectors, if I say AB bar and BC bar is there, then one vector is a scalar multiplication of another vector. So AB bar and BC bar are two vectors. Naturally, अगर वो collinear है तो एक ही line पे होंगे वो, right? Now AB bar can be written as B bar minus A bar. BC bar can be written as C bar minus B bar. Now, if I simplify this, थोड़ा simplify करके देख लेते क्या हो रहा है. A bar is equal to KC bar minus KB bar. सब कुछ एक साइड लेके आ जाते हैं. That means minus A bar plus B bar. ये तो लेफ्ट हैंड साइड as it is लिख दिया. फिर plus KB bar minus KC bar is equal to 0 bar. Now minus A bar plus, can you see अगर मैं B bar common लेता हूं तो 1 plus K is inside the bracket, B bar minus KC bar is equal to 0 bar. All right, now for some time let me say that x is equal to -1. ये -1 कहाँ से उठा के लेके आया? Can you see इधर -1 है इधर A bar का कोएफिशिएंट, राइट? एंड B bar के साथ कौन है? B bar का स्केलर क्या है? B bar के साथ स्केलर है B बार के साथ जो स्केलर है वो है k plus 1 and let me take it as 1 plus k, and whatever is with c bar let me take it as minus 1 उसका जो sorry minus k. That means the above equation becomes x a bar. सी a बार का कोइफिशिएंट था, a बार का स्केलर था -1, उसको हमने x कंसिडर किया. 1 प्लस k के बदले मुझे y लिखना है y b बार, एंड माइनस k के बदले मुझे क्या लिखना है z c बार. ये तो आ गया आपका. सो दिस पार्ट इज डन. अच्छा ये भी तो होना चाहिए. दिस इज पेंडिंग नाउ. नाउ इफ यू ऑब्जर्व x प्लस वाई प्लस जेड अगर मुझे करना है, व्हाट इज x प्लस वाई प्लस जेड? x का तो वैल्यू है -1 यहाँ पे, y का तो वैल्यू है मेरे पास 1 प्लस के, और z का वैल्यू कितना है मेरा -k. नाउ इफ आई ऐड ऑल दिस थिंग्स व्हाट आई गेट इज x प्लस वाई प्लस जेड इज इक्वल टू 0. सो द थियरम हैड टू पार्ट्स. कन्वर्स भी करना है अपने को. कन्वर्स इज टू बी डन. द फर्स्ट पार्ट इज इफ a b c are collinear, that means there are two conditions to be satisfied. x a bar plus y b bar plus z c bar is equal to 0 bar, and x plus y plus z is equal to 0. all right, now very important part था. अभी हम लोग देखते हैं सेकेंड पार्ट, दैट इज कन्वर्स. राइट, इसका कन्वर्स हम लोग चेक करते हैं क्या है. Now, before I start with converse, see, as I keep on saying, each and every word in the question that is given to you is always very important. Now, if you observe this, there are the three non-zero scalars. That means x, y, z, not all zero. हो सकता है एक हाथ जीरो है, but not all zero. Right. Now, let's say x not equal to 0, z is not equal to 0. फिलहाल ऐसे पकड़ के चलते हैं. Now we all know that पहले से हमने प्रूव करके रखा है. Now this is the given condition. This is the given condition. This is the given condition. Okay. Now, so what I'll do is, let me first write the given condition as converse. Let x a bar plus y b bar plus z c bar is equal to 0 bar, and x plus y plus z is equal to 0. This is the given condition. Now I have to prove that a b c are collinear points. Now see, let us say that for some time x is not equal to 0 and z is also not equal to 0. Now what will this become is y becomes minus x minus z. x plus y plus z is equal to 0 है, तो अगर x and z को हम दूसरी साइड लेके जाए तो y is minus x minus z, and that is minus of x plus z. Right. Now if I take this into this, because this is again the given condition, so what will happen is x a bar plus, now it will not remain plus because y will be replaced by x plus z b bar plus z c bar is equal to 0 bar. Okay, let me again make it clear. There are two cases. One is if a b c are collinear, then we have to prove that x a bar plus y b bar plus z c bar is equal to 0. That was this part, the first part. And converse is if x a bar plus y b bar plus z c bar is equal to 0 bar and x plus y plus z is equal to 0, then we have to prove that a b c are collinear points. That means they lie on the same line. Okay, for that non-zero hai x y z, so I just assume that x is not equal to 0, y is not, z is not equal to 0, and you can even say y is not equal to 0. So instead of y, I am replacing this part. Okay, so x a bar minus x b bar, if I multiply the bracket, okay, if I multiply the bracket, then minus z b bar plus z c bar. Okay, now from the first two terms, observe that first two terms here, if I take minus x common, what will be inside the bracket? That is b bar minus a bar. Okay, From the remaining two terms, if I take z common, what will remain in the bracket is c bar minus b bar. Okay, is equal to 0 bar. Now z into c bar minus b bar is equal to, if I take the other term on the right hand side, on the left hand side it is minus, here it becomes plus, so x into b bar minus a bar, which means c bar minus b bar is bc bar, z bc bar. All right, now is equal to x b bar minus a bar is ab bar. Now if I cross multiply x, what will happen is z upon x bc bar. Right, now my first question will be, will this exist? Because अगर x 0 हुआ तो, लेकिन हमने पहले ही assumption किया है x is not equal to 0 and z is also not equal to 0. So naturally this complete part is a non-zero scalar. It is a non-zero scalar, right? Now, which means AB bar is some lambda BC bar. Some lambda BC bar, where lambda is equal to z upon x. Okay, now because AB bar is lambda non-zero scalar multiplication of BC bar. And remember in the last to last class what we discussed, collinear है तो scalar multiplication है, and scalar multiplication है तो collinear है. Now because there is a scalar multiplication, I will say AB bar and BC bar are collinear vectors. Now remember that मैंने अभी collinear vectors prove किया, collinear points नहीं, right? Now see, when I say collinear vectors, there is a possibility that either they are parallel to each other or they are along same line. Now you observe that B is a common point. अगर हम AB बार और BC बार को ऑब्जर्व करेंगे तो B इज अ कॉमन पॉइंट. अगर वो कॉमन पॉइंट है तो नेचुरली वो पैरेलल नहीं है, अलोंग द सेम लाइन है. दैट मीन्स AB and BC are along same line. Now agar they are along same line, hence I can say that A, B, C are collinear points. As discussed earlier, हमको ये prove करना था collinear points, which we have proved converse part. Okay. Now remember that vectors is a chapter. अभी हम लोग जो कर रहे हैं, I am explaining you conceptually, but at the same time you have to remember that आपको ये एग्जाम में लिखना है. So the only way out is just practice. लिखो 2 बार 3 बार 4 बार 5 बार लिख लो, राइट? उसका नेक्स्ट स्टेप आ रहा है कोप्लेनरिटी ऑफ 4 पॉइंट्स. कोप्लेनरिटी ऑफ 4 पॉइंट्स, 4 डिस्टिंक्ट पॉइंट्स A B C D, of which no 3 points are collinear, because 3 points collinear हो जाएंगे तो भी गड़बड़ है. With position vectors A bar, B bar, C bar, D bar respectively are coplanar if and only if there exist 4 scalars x, y, z and w, not all 0 again, such that xa bar plus yb bar plus zc bar plus wd bar, where x plus is equal to 0 bar, where x plus y plus z plus w is equal to 0. राइट, सिमिलर है जो हमने पहले किया था, राइट? तो कोप्लेनर है तो आपको याद है कोप्लेनर है तो लीनियर कॉम्बिनेशन होना चाहिए. सो लेट मी राइट इन दिस वे. नाउ A, B, C, D are the points with position vectors A bar, B bar, C bar, D bar respectively. Right? We have already started with the proof part, so I'll write here proof. Okay. Now, this is mentioned in the problem. This is mentioned in the problem. Now, let me say if A, B, C, D are coplanar. Once again, going back to the first class, if it is collinear, then scalar multiplication, coplanar to linear combination. That means AB bar is some linear combination of AC bar and AD bar. AB bar is equal to MAC bar plus NAD bar. Now, if I simplify this, this is B bar minus A bar, just like we have done in the previous case. AC bar is C bar minus A bar and AD bar is D bar minus A bar. Just like we did in the last theorem, again, I'll open the brackets M C bar minus M A bar plus N D bar minus N A bar. Once again, just like we did in the last theorem, take everything on one side. So A bar, N A bar plus B bar is the single term minus M C bar and minus N D bar is equal to 0 bar. So I've taken everything on the left hand side. I'm missing one A bar. Yeah, I'm so sorry. Yahan pe I'll rewrite this. B bar, minus A bar plus MA bar plus NA bar. B bar is a single term. Then minus MC bar minus ND bar. So I've taken everything on the right and left hand side. Now, from the first three terms, if I take one A bar common, minus 1 plus M plus N plus B bar minus MC bar minus N D bar is equal to 0 bar. Observe this, the coefficient of B is 1, the coefficient of A is this. Okay, now let me say that coefficient of A bar जो है उसके बदले मैं x लिख दूं m plus n minus 1. B bar का coefficient है 1, which I am writing it as y. What about C bar? उसका scalar है z is equal to minus m and w is equal to minus n, which means the above equation becomes xa bar plus yb bar plus zc bar plus wd bar is equal to 0 bar. ये तो मिल गया मुझे, ये वाला statement तो मिल गया मुझे, correct? Now what about the addition? Let me check with the addition. X plus y plus z plus w is equal to, what is x? M plus n minus 1. What is y? 1. What is z? Minus m minus m. What is w? Minus n. Check. एक एक करके ऐड करोगे तो x plus y plus z plus w is equal to 0. I'm sorry, it is scalar. Now if you observe, दो conditions थे, 1 and second. Both the conditions we have arrived when we said that A bar, B bar and C bar and D bar are coplanar. Okay, now इसका converse करते हैं, उल्टा, right? In converse we are given with 2 points, 2 things, right? 2 things that we are given. One is let x A bar plus yb bar plus zc bar plus wd bar is equal to 0 bar, and x plus y plus z plus w is equal to 0. We already know that x, y, z and w are not all 0. Let me right now say that x is not equal to 0. Now, if x is not equal to 0, the above equation can be written as xa bar is equal to minus yb bar minus zc bar minus wd bar. All right. Now, what will happen is xa bar. Now, because x is not equal to 0, we can divide by x. So, if I'm dividing by x, this becomes minus y upon x b bar plus minus z upon x c bar plus minus w upon x d bar. Can you see? This is one scalar, this is another scalar, this is another scalar, right? That means we can say therefore a bar is a scalar multiplication of, I'm so sorry, not scalar multiplication. It is linear combination of B bar, C bar and D bar. Which means A bar, B bar, C bar, D bar are coplanar vectors, which also means therefore A, B, C, D are coplanar points. Right? So in the first part, if they are coplanar, we proved that xa bar plus yb bar plus zc bar plus wd bar is equal to 0 and x plus y plus z plus w is equal to 0. In the second part, we considered xa bar plus yb bar plus zc bar plus wd bar is equal to 0 and we proved that a bar, b bar, c bar and d bar are coplanar. All right. So that's it for today. For this class. I'll be going for the fourth class, in which I'll be discussing internal division and external division theorems, which are very important. जब मैं start करूंगा तभी आपको समझ में आएगा कि कितनी बार आज तक पूछा है ये theorems, right? Along with that, so I'll be doing actually 4 theorems in the next class, but all the theorems have been asked in the exams many times, right? So that's it for today. Thank you very much.